Hello my friends, welcome to my Energy Economist channel. In this video we are going to talk about well planning and costs. Stay with me. The drilling of a well involves a major investment, ranging from a few million US dollars for an onshore well to $100 million US plus for a deepwater exploration well. Well engineering is aimed at maximizing the value of this investment by employing the most appropriate technology and business processes to drill a fit-for-purpose well, at the minimum cost, without compromising safety or environmental standards. Successful drilling engineering requires the integration of many disciplines and skills. Successful drilling projects will require extensive planning. Usually, wells are drilled with one, or a combination, of the following objectives. To gather information. To produce hydrocarbons. To inject gas or water to maintain reservoir pressure or sweep out oil. To dispose of water, drill cuttings, or CO2, sequestration. To optimize the design of a well, it is desirable to have as accurate a picture as possible of the subsurface. Therefore, a number of disciplines will have to provide information prior to the design of the well trajectory and before a drilling rig and specific equipment can be selected. The subsurface team will define optimum locations for the planned wells to penetrate the reservoir and in consultation with the well engineer agree on the desired trajectory through the objective sequence. In discussions with production and well engineers, maximum hole inclination and required wellbore diameter will be determined. Wellhead locations, well design and trajectory are aimed at minimizing the combined costs of well construction and seabed/surface facilities, whilst maximizing production. The accuracy of the parameters used in the well planning process will depend on the knowledge of the field or the region. Particularly during exploration drilling and the early stages of field development, considerable uncertainty in subsurface data will prevail. It is important that the uncertainties are clearly spelled out and preferably quantified. Potential risks and problems expected or already encountered in offset wells, earlier wells drilled in the area, should be incorporated into the design of the planned well. This is often achieved by using a decision tree approach in the well planning phase. The optimum well design balances risk, uncertainty, and cost with overall project value. The basis for the well design is captured in a comprehensive document. This is then translated into a drilling program. In summary, the well engineer will be able to design and cost the well in detail using the information obtained from the petroleum engineers, geoscientists, and production engineers. In particular, he will plan the setting depth and ratings for the various casing strings, cementing program, mud weights, and mud types required during drilling, and select an appropriate rig and related hardware, for example drill bits. An increase in depth increases drilling costs. Costs increase exponentially with depth, even for a normal, trouble-free well. An increase in depth can also increase the chances of mechanical problems, which adds to the cost of drilling. Increased depth also reduces available information about potential reservoirs, about quality of crude oil and quantity available, proven reserves. Risks increase with uncertainties about reservoir quantity and quality available. Costs of drilling depend on the kind of oil and what potential energy the oil possesses by virtue of its initial pressure in its reservoir, and by the amount of dissolved gas it may contain. In many cases, the crude may have enough potential energy to permit a well to flow large quantities of oil to the surface without any artificial assistance, such as use of gas or water injection. This is quite prevalent in oil wells in the Middle East. But when oil cannot flow unaided, or when the pressure in the reservoir has decreased to a pressure that is too low to be economical, costly mechanisms that lift oil to the ground surface must be employed. Low pressure in the reservoir and low gas content generally goes together. This kind of crude, therefore, must be handled in a different manner. The daily rates of offshore drilling rigs vary by their capability and market availability. With Deepwater, drilling rig rates of around $420,000 per day were reported in 2010. A high-pressure, high-temperature well of duration 100 days can cost about $30 million. Onshore wells can be considerably cheaper, particularly if the field is at a shallow depth, where costs range from less than $1 million to $15 million for deep and difficult wells. Net profits associated with operating a rig are determined from the contract day rate less the daily operating costs. Generally speaking, deep-water, high-spec, international rigs cost more to operate than shallow-water, low-spec, domestic rigs. Rig size and age, port infrastructure, scale economies related to a contractor's regional presence, market competition, and the availability of goods and services are primary factors that impact operating cost. Operating margin is the ratio of operating income, earnings before interest and taxes, to revenue and is an aggregate measure of the cost structure of the firm. Firms with higher operating margins have larger net earnings per dollar of revenue than firms with lower margins. Firms with older fleets or a large number of stacked rigs are expected to have lower operating margins than firms with younger or more active rigs. A statistically significant negative relationship exists between the percentage of the fleet that was stacked in 4Q 2011 and operating margin, but many other factors are responsible for operating margin and the relationship only explains a small proportion of the variation. Several companies operate offshore rigs as a small, non-core part of their business operations. Saipem, Maersk Drilling, Nabors, Petrobras, and Oil and Natural Gas Corporation, ONGC, of India generate less than half of their revenues from offshore drilling. Saipem derives the majority of its revenue from offshore construction. Maersk Drilling is a subsidiary of the shipping conglomerate AP Moller Maersk. Nabors is primarily an onshore drilling contractor, and Petrobras and ONGC are national oil companies. Other firms such as Aben, Fred Olsen Energy, COSL, and Hercules also have investments in other industries, but these investments do not generate more than 25% of the firm's revenue. Aben has investments in wind energy, Fred Olsen Energy in offshore construction, COSL is an integrated offshore oilfield services company, and Hercules operates a lift boat division. In 2012, Singapore dominated jackup construction, Korea was building most of the world's drill ships, and semi-submersible new builds were split between China, Mexico, and Singapore. From 2005 to 2012, Keppel and Sembcorp were dominant in jackup and semi-construction, while Samsung and Daewoo were dominant in drillship construction. Competitive advantages change over time and geographic redistribution will arise, but for the near-term future these players are expected to maintain a dominant position in the industry. If you want to learn more about well planning and costs you could do so in my book, Economic Study of Oil and Gas Well Drilling, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and do not forget to also hit the notification bell. Thank you for watching and goodbye.